let's get to bell work. So bell work should be a good reminder of what we did last semester. Okay, it says we've got this little table right here. You're going to see table problems all the time. A zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon and 8 p.m. The number of entries in the box is modeled by this differential equation E. The values of E of t is in hundreds of entries at various times are shown in the table above. Use LRAM with 4 subintervals given to approximate 1/8 0 to 8 E of t dt, and then we're going to explain it using correct units. All right, so again, here's what we're trying to do. We are trying to evaluate what this means. E of t dt 1/8. We are going to approximate that. That's what we're trying to figure out right now. We're going to approximate. It said we need to use 4 subintervals. How many numbers did they give me? 5. Is it good to have 5 if I'm doing 4 subintervals? That's what I want. Okay. I know you don't have this on your paper because it's on bell work, but you should be drawing some hats from one guy to the next to make sure that you know how to connect those guys. So that's what I'm trying to do here. All right, let's work through this. So my first one, okay, we're doing LRAM. So again, remember, we're making rectangles. That's what we're doing. It's a rectangle. We're finding the area of a rectangle. So my first one here, Cannon, what's the width of my first rectangle? The width. What's the distance between them? Yeah, you're good. The distance is 2 because I'm going from 0 to 2. What's the height going to be if I'm doing LRAM? 0. Good, because he's picking the left number. Okay, the width is 2 because we're going from 0 to 2. The height is 0 because we're picking the left. Okay, then we go to my next one. Maddie, what's the width of my next one going to be? 3 because we're going from 2 to 5. What's your height going to be? 4. Cool. Don't forget we are adding these things all together, so we should have some plus signs in between. So it's that plus that. And then I'm doing my next one. Dylan, what's the width of the next one going to be? 2. What's the height going to be? 13. Picking the left one. Good. We got that. And then my last one here. Taylor, what's the width of my last one going to be? 4. It's 1 because I'm going from 7 to 8. What's the height going to be? 21. Boom. That thing right there. That right there is not correct. What did I not put that I need to put? 1/8. So don't forget, throw that thing in parentheses. If you're going to forget that, then do it the very first thing you do. Put the 1/8 and then put some big parentheses. That is the answer. If I left it just like that, you're scoring 2 points on the AP exam. Okay? 1 for doing the setup correct and 1 for getting the right answer. Even though I didn't do anything there, I got the right answer. Just to make things a little bit easier, I will actually do the math. 2 times 0 is 0. Don't normally do this. Plus 12, plus 26, plus 21. Does that get you 59? 59 over 8. And I don't even like the equal sign there because it's not really equal unless I put that 1/8 in front. Okay? That is what I got. 59/8. Great. What does that mean? Okay? And so that's what we have to do now. Okay? With correct units, explain the meaning of that. Okay? So 1/8, 0 to 8, E of t dt is, what is that? What does that tell me here? What does this 1/8, and this is the thing that matters more than anything else, what does this 1/8 in front of the integral tell you about the problem? When we do that, what does that mean we're doing in the problem? Good. It is, this thing is the average. It's the average what? No. It's not that. It's the average of whatever we integrated. And what did we integrate? What was the units on that thing that we integrated? Number of entries. That's what it is. This is the average of the number of entries in hundreds That's kind of a dumb thing, but understand what we're doing. Okay, you've got a box. This is a box. At time 0, there were 0 entries, and then people kept putting entries in. At 2 hours, there were 400 entries. At 5 hours, there were 1,300 entries, and so on. So this number, this 59 over 8, anybody get a decimal on that? I don't know what that decimal is. No. I just would rather talk about it instead of 59 or 8. That is 7.375. That means there were 7,000 entries on average in that box. During any period of time, on average, there were 7,000 entries. So this is the average number of entries in hundreds from, because it's a time period matters, from when to when. From t equals 0 to t equals 8, or I could say from noon to 8 p.m. If I integrate, it is a from. It is over a period of time. It's a weird thing, but do we kind of remember what's going on there? Don't forget the number in front. That's your average. We just did LRAM. LRAM's easy. Don't forget that. All right. One more thing here. Let's act like I erased that. You didn't know it. All right. With your neighbor, find the area of that trapezoid. I know you can break it down into a rectangle and a triangle. Try to remember what the formula for area of a trapezoid is. Talk to each other. Go. Here we go. Area of a trapezoid. Show me with your fingers. What's the area of this trapezoid going to be? Oh, yeah. We've forgotten how to do it. Anybody remember how to do this? Slade, what'd you do? Good. Here's what he said. Listen, please. He said, we are finding the average of the two heights. Okay. Remember what we could do. Some of you could have done this, and this is a 4x6 box, so that's 24. And this triangle's half, it's 12. The answer is 36. That works great most of the time, except for today when we're doing trapezoidal rule. And so we want to be able to find the area of a trapezoid. And so the idea for the area of a trapezoid is you are going to do this. 4 to 8, the average of 4 and 8 is 6. Okay, so if we didn't look at this anymore, and this was 6, now I have a box where this triangle here that's too much would fit perfectly right there, and it would just make a box. The height would be 6, the width would be 6, so the area would be 36. Does that make sense? To do that, we found the first height plus the second height, and we found the average of the two. So we found the average of 4 and 8. That got me 6. And then we're going to multiply that by the width, by the base. And in this case, my base is 6. 6 times 6, the answer is 36. Average the heights times the base. That's how you find the area of a trapezoid. Kind of remember? Let's do it. So look at those notes that I passed out to you. Let's go through those. Trapezoidal rule. This is just like LRAM and RRAM. Okay? It's a little bit more complex, but not a whole lot. Okay? What we'll find is it's a better representation of our data. Okay? So this first problem, all we are going to do is draw. We're not actually going to find the answer. We're just going to draw it. Okay? We're going to do a trapezoidal sum of 4 equal subintervals of this thing. So we're finding the area under the curve from 1 to 9 using a trapezoidal sum. Okay, so we're going from 1 right here to 9. We're doing 4 equal subintervals. So how big does each subinterval need to be if I'm doing 4 equal subintervals from 1 to 9? 2. Everybody know what I'm saying there? 9 minus 1, it's 8. Break it into 4 parts, it's 2. And so every 2, I'm going to draw a line. So right there's a line, right there's a line, right there is that line from 5 to 7, and then from 7 to 9. Okay, so I've split up my picture. This is a little bit different than LRAM or RRAM. So don't draw this. But if I did like LRAM here, it would look like this, where I would attach it from the left-hand side. Okay, from the left-hand side. And that's not a very good representation. I could do RRAM, but that would not be a very good representation. Instead, we're going to do trapezoids. And so what that means is the two heights that touch this graph, I'm going to connect them with a straight line. So there is my first trapezoid right here. And then from 3 to 5, I'm going to connect those two with a straight line. So that is the second area right there. There's a trapezoid. And then my third one, I'm going to connect the heights from 5 and 7 with a straight line. So there is my third trapezoid. And then my last one, I'm going to connect from 7 to 9 with a straight line. And I can highlight that in. That is my fourth trapezoid. Is it a perfect representation of the area under the curve? No. Is it pretty decent though? Yeah, like right here in this portion in particular, it's pretty close. Right there, it's pretty close. And imagine instead of skipping every 2, if we skipped every 1, then it would be even better. Talk with your neighbor. Is this an over approximation or an under approximation? Thumbs up if you think it's an over approximation. Thumbs down if you think it's under. I agree. It's under. You got a whole lot of space right here and right here. While these two are over, it's not by a whole lot. Kind of make sense? All right. Now let's actually do it. So we kind of seen it. Now let's do it. Here we go. We are going to integrate from -1 to 3, x squared plus 1 dx. So this is my equation. There is the graph. We are going to integrate from -1 to 3 using trapezoidal sums. And we're going to make 4 equal subintervals. So obviously our first x value is going to be -1. Our last x value is going to be 3. I want to split it up into 4 equal subintervals. That's why there are 5 boxes, because we're always going to have one more than the amount that we need. How far apart is each value going to be? 1. So it's -1, and then 0, and then 1, and then 2, and then 3. Okay. To find the y value, you either have the picture down here where you could look at the graph and find the y value, or you have an equation. Okay. I don't really care which way you do it, but if we did -1, you could look right here on the graph and see that the answer is 2. Or you could take -1 and plug it into the equation and see that you would get 2. Okay, same thing at 0. At 0, we're right here at 1. At 1, we are at 2 again. At 2, we are at 5. And at 3, we're at 10. It's just the different points on that graph. Everybody good? I would not suggest you writing it this way in the future, but I'm going to do it the first time. Okay? We're going to find the area of each trapezoid. So I'm going to find the area of trapezoid number 1. Again, don't write it like this in the future, but I'm just showing it here so it's very clear. Okay, trapezoid number 1, that is going to be this guy. From here to here. I'm making a trapezoid. It's this box right here. I'm going to find the area of that thing. To find the area, you are going to take the average of the 2 heights. So in this case, I'm taking 2 plus 1. Those are the 2 heights. I'm going to divide it by 2, and I'm going to multiply it by the width. What is the width? 1, because I'm going from 1 across. So I took the 2 heights, I added them together, divided by 2, and then multiplied it by the width, which gets me 1. Okay, so 2 plus 1 is 3 halves. It's 3 halves, 1.5. Now let's find trapezoid number 2. So trapezoid number 2. Trapezoid number 2, we're going between 0 and 1. So it's this trapezoid right here. Jesse, what are the 2 heights of my trapezoid going to be? Say again? 2 and 1 again. Okay, this, I guess I could write it 1 plus 2. This one's 1, that one's 2. And then what do you have to do with those 2 heights? Over 2. He's got to find the average of those things times the width. What's your width going to be? 1. Good. Found the average of these 2 times the width. The average of these things. Again, we could still draw the little hats from one to the next. Still matters. Okay, so I get 1.5 again. Trapezoid number 3. So trapezoid number 3, it's this guy to this guy. Boom, it's this one. Lacey, what's the two heights here on this problem. 2 and 5. What do you need to do with them? Divide by 2 because he's going to find the average. And then he's going to multiply it by your width, which is 1 again. So 7 divided by 2, it's 3.5. Okay, so that's the area of this trapezoid. And then I got one last one here. Caden, what are the heights of trapezoid number 4 going to be? 5 and 10, because he's using these two. Okay, he's using this guy and that guy, 5 and 10. He's making a trapezoid right here. You can barely see that line. That's how well it hugs the curves. Okay, it's pretty close to that line. But that's our trapezoid. So he's taking 5 and 10, he said. 5 plus 10, what do you need to do with them? Divide by 2 and multiply by the width, which is 1. 15, 7.5. We take all those, we add them together, we get 14. Okay, I add them all together, you can do it. But that's the trapezoidal sum. Again, don't write it like this in the future. Don't write trap number 1, number 2. I'm just showing it to you so you visually see what's happening. That's 14. Talk with your neighbor for a second. Is that answer an over or an under approximation? And why do you think that's true? Talk to each other. Go. There we go. Thumbs up if you think it's an over approximation. Thumbs down if you think it's an under approximation. I agree. It is over. If you look close enough here, if I zoom in, you can see that, oh yeah, it's a little bit above. It's a little bit above. That one right there is pretty close. I drew a bad picture, but it should always be a little bit above. And then right there, it's always above. Just pretty close, though. Anybody have a reason to why it's an over approximation? 2 things need to be said. One of them is we use trapezoidal rule, or we use trapezoidal sums. Anybody have an idea why the second reason it's trapezoidal sums and concave up, like a cup? Again, look at this picture up here. Look to see where it was concave up. Like in this section right here, it's an over approximation. When it was concave down, like right there, it was an under approximation. It was an under approximation. That's what you're looking for. Remember with LRAM and RRAM, what were we looking at to decide if it was over or under approximation? Whether it was increasing or decreasing. This time we're looking for concavity. So trapezoidal rule, you're thinking concavity. If it is left or right ram, you're thinking about increasing, decreasing. Flip that over. This table gives the velocity in miles per hour of a truck at selected time in hours using a trapezoidal sum with 3 subintervals. So I've got 4 numbers, so I should have 3 subintervals. There's 1, there's 2, there's 3. Good. What is the approximate distance in miles? So they gave me velocity. They're telling me to approximate distance. To do that, I'm integrating. I'm integrating from 0 to 3. V of t dt. We're doing 3 subintervals, and we're doing a trapezoidal sum with your neighbor. Find that answer. Go. We're doing 3 subintervals, so we got to do the height and the width of each one. Austin, we're doing trapezoidal sums, so what are the 2 heights going to be if I'm doing trapezoidal sum of the first one? 20 and 60. So he's using these 2. What do you have to do with 20 and 60? Find the average. So 20 plus 60 divided by 2 times the width. What is your width going to be? 0.5. So that times 0.5, boom, that's his first trapezoid. Then he's going to put a plus sign. So because we were 0.5 across. Then we're doing my second one. Roslyn, what is the 2 heights that we're using on our second one? 60 and 40. What do you got to do with them? Good. Add them up, divide by 2. You're finding the average. Find the average of the 2 heights. What's your width going to be? 1.5 times the width. 1.5. There's my second one. Okay. My third one here. Cannon, what's my 2 heights going to be for my third one? 40 and 30. What do you got to do with them? Yep. Divide them by 2 and then multiply by the width, which is 1 because I'm going from 2 to 3. That is my answer. I'm done. I got all my points for that. We could find an actual number. The actual number is 130. What would my units be? I integrated velocity, which was in miles per hour, and I just integrated it. So what is it going to be now? It is just miles. That is the change in miles over that time period. When I integrate, it tells you the change in miles. Everybody all right with that? That's exactly how we should set that up. You'll get used to it as we go. Example 3, the temperature in Celsius of a turkey in an oven is a continuous function of time. Some values of this function are given in the table. Find the average temperature. They gave me temperature and want you to find the average temperature. Okay, they didn't tell it to me, but let's just say the temperature is T of T, capital T of lowercase t. That's normally what they say there. We want to find the average temperature over the interval from 0 to 30 using trapezoidal rule. Let's make this easier just so we don't have to waste our time here. Let's go from 0 to 20. 0 to 20. So I'm going to even just make this easier for us. So I might disregard those last two just to speed up the process. What do I need to do to find the average temperature if they gave me the temperature? Integral. I'm going to find the integral from 0 to 20 because I want to do it. I want to find the average temperature from 0 to 20. What am I going to integrate? The temperature, T of T dt. What else do I need to do if I want to find the average temperature? Multiply by 1 over 20. Why 20 here, Taylor? Yeah, that's how far we're going. We're going from 0 to 20. That represents 20 minutes, so we're going to divide by 20. Okay, that is my setup. So if I wanted to get an answer to this, it would be 1 over 20 times, and now I made this a really short problem, but then I just want to find these two trapezoids, and we'll just do that quickly here. Ella, what's the two heights of my first trapezoid going to be? Those are two widths. What are the two heights? The y values are my heights. You're good. These two, 24 and 106. What do you need to do with those two numbers? Yep, 24 plus 106 divided by 2. And then I'm going to multiply that by the width. What's my width going to be? 8. Good. There's my first one. And then I'm doing my second one here. Harley, what's the two heights for my next one going to be? What do I got to do with them? Yes, ma'am. And then what's my width going to be? What's the width? 12. Good. Because I'm going between those two. The width is 12. We add that up. That's my answer. I'm not going to do it. I'm just going to leave it. But that is the average temperature of the turkey during the first 20 minutes of it cooking. Questions there? Uno mas. Let's finish with this last one. A left Riemann sum, a right Riemann sum, and a trapezoidal sum are used to approximate the integral 0 to 1 f of x dx. So this is f of x down here. We're using a left Riemann sum, a right Riemann sum, and a trapezoidal sum to approximate that answer. Which one of these given methods, of these given sums, is going to underestimate the actual answer? Talk with your neighbor. A, B, C, D, or E. Come up with an answer. Which one is going to be an underestimate and why? Here we go. Show me your 1 for A, 2 for B, 3 for C, 4 for D, 5 for E. What we got? 2s and 4s. Let's see which one. So let's go each one. Left sum is first. So if I'm doing a left sum, draw a line, and then that's going to be the left side. So that's going to be the left corner. And then that's going to be the left corner. And that's going to be the left corner. If I do a left Riemann sum, is it over or an under approximation? This is an under approximation. Look at all this extra space, that extra space, that extra space. Why is that an under approximation? Good. It's increasing and LRAM. That is why it's an under approximation. I don't have that memorized. Okay? If I got to the graph and I was like, what's the answer? I would draw a picture. All I remember is that it's whether it's increasing or decreasing or not. Draw an increasing graph, connect from the left-hand side. Oh yeah, it's under approximation. Okay? Let's go to my next one, right Riemann sum. So we pretty much know the answer to this, but a right Riemann sum means I'm going to have a graph, and that's going to be the right-hand side. That's the right-hand side, and so on. Over or under approximation? Over, because it's a whole lot above it. Why? Because it's increasing, and it's a right RAM problem. That's our reasoning. trapezoidal sum. So trapezoids are the easiest ones. Draw two lines and then connect them. Under or over? It's definitely an under approximation. Why? Because I use trapezoids. And what is the second reason as to why it's concave down? It's down like a frown. Again, I don't have it memorized. All I know is, oh, trapezoidal, I'm looking at concavity. Draw a graph, draw a parabola, either concave up or concave down, and connect some stuff, and you'll see whether it's an over or under approximation. So 1 works, 3 works. The answer is D. Questions on something we covered today?